Good morning or good afternoon or good evening, depending on where you're at. My name is Atarot Azizin Amini, Director of the ABC UTC at Florida International University. 2022 International ABC Conference will be in Miami, Florida. The conference will be in the same place. We are going to be populating our website very soon. The conference will be on basically Thursday and Friday, and then the Wednesday will be the workshop. So that will be face-to-face. It is not going to be hybrid. It's not going to be virtual. It will be face-to-face. You can go ahead and submit one-page abstract, and the deadline to submit your one-page abstract is February 25th, 2022. So we hope that many of you who are listening to us will consider attending this face-to-face, back to normal type conferences in December of 2022 in Miami, Florida.
Our presentation today features the Massachusetts Bay Transportation Authority's weekend railroad bridge replacement over Parker Street in Lawrence, Massachusetts. We're pleased to welcome our presenters, Carl Ekstrom, Senior Director of the Bridge and Structures Program with the Massachusetts Bay Transportation Authority, Michael Ryan, Senior Bridge Project Manager with MBTA Capital Delivery, and Bob Penfield, Managing Director of Highway and Structures with BHB. Carl?
Thank you, Mary Lou. Good afternoon, everyone. I would like to thank the leadership group at ABC, UTC, and Florida International University for inviting the MBTA team to share with you all a recent bridge replacement project that ultimately was accomplished in a single weekend using accelerated bridge construction techniques. My name is Carl Ekstrom. I'm the Senior Director of MBTA's Bridge and Structures Program in our Capital Delivery Department, essentially our design and construction arm at the authority. In addition to Mike and Bob, I'd like to take a moment to introduce two other members of our panel that will be participating in today's discussion. We have Andrew Burkholder, who is the Director of Structures in Massachusetts for our design partner, VHB, and Brian Delaney. He's the project manager with Barletta Heavy Division. They are the construction contractor that built the bridge that we'll be discussing with you today. As an overview of today's webinar, we plan to give you all a brief description of the Massachusetts Bay Transportation Authority, the MBTA, or as the locals in Boston call it, simply the T. We will then focus on the September 2021 weekend successful replacement of this Parker Street Bridge Railroad Bridge Replacement Project in Lawrence, Massachusetts. So how did we get here today? This LinkedIn post from September caught the ABC eye of Adarod, who reached out to me to inquire about some of the details on the project, and so here we are. And a word to all my bridge owner colleagues out there, when you post to your social media network, you too may end up with a chance to highlight your ABC project successes with a much bigger audience. So thank you, Adarod. The Massachusetts Bay Transportation Authority, which is known as the MBTA, or simply the T, is a public owner operator of most bus, subway, commuter rail, and ferry systems in the greater Boston, Massachusetts area. The MBTA is the largest transit provider in New England, is the 5th largest system in the United States. We are also the oldest transit agency in the United States. The MBTA network services an area with up to 175 towns and communities, with a total population of almost 4.7 million citizens, which happens to be over 3/4 of the total population of the Commonwealth of Massachusetts. Our commuter rail network began daily service back in the early 1970s as a network of almost 400 track miles. We have over 135 stations, and we contain approximately 300 bridges of our total structural inventory on the commuter rail network. Back in 2018, as part of the MBTA's then record capital investment goal of $850 million, the rail bridge replacements design build project was advertised and comprised of approximately $93 million of that $850 million capital investment goal. The authority's annual capital investment goals continue to increase as we strive to build a better T, and bring the system not only to a state of good repair, but also to deliver a modernized and efficient transportation network to our riders and customers. So let's put all of that into a little bit of context. If you are unfamiliar with our locale, Massachusetts is one of the 6 New England states that comprises the northeast corner of the United States. Here is the state of Massachusetts with the capital city of Boston on the eastern coast of the Atlantic Ocean. Next, we will overlay our subway lines, which are known simply by their color scheme to the everyday user in Boston. As we next expand the view to include our commuter rail network lines, you'll get a sense of the way our services reach out into areas of the state to give our riders a chance to get into, out of, and around the city of Boston. The Parker Street Bridge is one of several bridge replacement locations that are ongoing in 2021. All of which have some ABC elements involved in their construction activities. The Parker Street Bridge location is highlighted here. It carries the western route of our Havel line over a local city street in Lawrence, Massachusetts. I'm going to turn things over to Mike Ryan, our MBTA project manager, who will get into the details of the Parker Street Bridge project. Mike?
Thank you, Carl. The Parker Street Bridge project, it is a part of MBTA design bridge replacement, which is a design build program consisting of 6 bridges. Part of the contract documents were prescribed track outages for each of the 6 locations and also for Parker Street. There were no incentives, disincentives in the contract. There was liquidated damages if the contractor were to exceed the outage time come Monday morning. Each design build team presented different concepts to the MBTA, obviously during the procurement phases. The selected team was that of Barletta Heavy Division, which is the construction lead, VHB, the design lead, and for Parker Street, Mojeski and Mastersons. They were the structural EOR for Parker Street. So here is the 6 locations, very similar map that Carl just showed. We'll zoom in on Parker Street, which is up in Lawrence, close to the border of New Hampshire. Just so everybody gets a better feel of it. This is the existing conditions when the project was bid. You can see the MBTA right away, kind of goes from the left of the screen to the right of the screen. Some of the proposed potential staging areas were just in the northern section and also to a private lot in the lower right-hand corner. So Parker Street, the existing conditions. Bridge was originally built in 1913. There is 5 track structures, 5 bays. 3 of them are currently active. It was a steel girder with ballasted deck, concrete gravity abutments. Parker Street itself, roadway, face-to-face curve is 40 feet. Sidewalks on both sides, 9 foot on the west, 7'9" on the east. That does include the areas of the piers also. Utilities, which is always makes every site unique. Signal and fiber optics on the bridge. The MBTA does have the positive train control located overhead, operating and controlling train traffics. For train operations going over Parker Street, 32 commuter rail trains per weekday, 12 on the weekend, and then additionally Amtrak runs its Downeaster service over this bridge, and Pan Am also very heavy in freight on this bridge. The project needs. Obviously, the existing bridge is in very poor condition. The superstructure steel rated 4 out of 10. MBTA uses the NBIS rating system, just for your reference. It's the MBTA's goal to provide safe and efficient transport for all T riders and the public. Just to maintain, obviously, this bridge is not in a good state of repair, so it needs to be maintained for a good state of repair to ensure that the train runs on time. Project goals for Parker Street, as stated, restore the state of good repair for the piece of infrastructure, replace the bridge with something that has a long lifespan, part of the contract requirements, 75-year expected service life. Also, there was language in there to minimize, during the construction, minimize impacts to local abutters, the commuter rail riders themselves, the users of Parker Street, and also freight operations, which runs on this line and over this bridge. The proposed design was a complete bridge replacement, obviously. Track and profile and alignment was going to match existing. We weren't changing anything there. The design build team proposed using the accelerated construction techniques to reduce the impacts. The new structure is going to be a single span built in front of the existing abutments. And all the construction is going to be within the right of way. No anticipated or required easements or anything like that. So here is a elevation view of the new structure. It consists of new concrete abutments built in front of the existing abutments. The vertical clearance was going to be held at the 14.6 minimum. And the substructure was going to use the micropiles drilled down into rock. Here's a cross section of the new structure. It's a ballasted through girder. It supports 4 tracks. The 4 tracks are kind of made up of 2 different units, superstructure units that are separate but sit on a common abutment. Some of the ABC techniques that were used for Parker Street, obviously with the site constraints, the low headroom equipment for the micropiles and tiebacks were implemented. Precast abutments, back walls and approach slab, precast elements of the bridge were the back walls and approach slabs. And we used SPMT, Self-Propelled Modular Transports, for the superstructure installation. And if you never got to see one of those jobbers move, you should definitely try because they're pretty interesting. With that, I'll turn it over to Bob, who'll go more into the construction.
Thank you very much, Mike. So these next sequence of slides, they're a series of renderings of a 3D model that we developed of the entire project site. They were developed during the design phase through coordination with the contractor, the designer, and the MBTA. And the intent was really to clearly illustrate each phase and subphase of the proposed work, evaluate site space constraints, conflict detection, etc. But they also served as an important visual tool for communicating this project to the public and local stakeholders, essentially showing them when and why certain construction activities needed to happen, and when and for how long any impacts would be implemented to either the commuter rail, freight rail, or the multimodal users of the roadway below. So just to orientate everyone, what's shown on the screen right now, this is essentially looking northward. Track 17, track 1, and track 2 were all active tracks carrying both commuter rail and freight. The track known as the Old South track was in place but out of service, and then just beyond the Old South track with a remnants of a 5th track, a former spur line that was no longer in place. So the first phase was to establish traffic management controls and to establish a safe work zone on the eastern, in front of the eastern abutment. And what this allowed traffic to pass in both directions, single lane of vehicular traffic, and at least one of the sidewalks was open underneath the roadway while this set of Jersey barrier and fencing was installed. Once that was in place, we had a safe work zone in front of that eastern abutment, and using low headroom equipment, we installed both the tie-back anchors and the micropiles. You can see here the low headroom equipment underneath the existing bridge. And then here again, the installation of the micropiles using, again, low headroom equipment, so we're staying underneath the existing bridge superstructures. Once those foundation elements were installed, we were able to construct the new concrete abutment and facing. As Mike showed in a previous slide, the new abutment was installed and constructed in front of the existing. The next step, which is only shown here roughly, was a repeat on the western abutment, the same set of construction activities where we built out temporary traffic management, still allowing 2 lanes of traffic, vehicular traffic. The eastern sidewalk was open at that point, but then the work continued essentially in the same way with the installation of the foundation elements and the construction of the new western abutment facing. The next stage showed the demolition of part of the existing bridge. As I mentioned before, tracks 17, 1, and 2 were active, but the other 2 existing bays were not. We were able, and we proposed in this series of renderings to remove those 2 existing bays, thereby creating additional space for us to construct portions of the new and proposed superstructure. For these activities where demolition was occurring and the existing superstructure was being removed, we had closed down Parker Street for short periods of time, off-peak hours, outside of times where heavy traffic was occurring. At that stage, we opened up enough of the site that would allow us to install the precast concrete approach slabs for one of the 3 new railroad bays. Again, that work using a large crane in the road required, again, a short-term closure of Parker Street just while the material was installed. At that point, some of those foundation elements and new bridge elements had been completed, and the Parker Street was opened back up. At that point, the new superstructure girders and the rest of the superstructure elements were brought to the site and assembled on site on temporary supports, or partially on temporary supports and partially on the newly constructed abutment, the new northern superstructure. So we see one girder here on the screen going in, and again, the rest of it all assembled. Once this was assembled, and this was done without any impacts to commuter rail or freight rail traffic, the temporary supports holding up these superstructures were outside of the travel way. So again, this allowed Parker Street to remain open. The next phase was the start of a full weekend shutdown. This was a shutdown of both Parker Street below, but also the commuter rail and freight rail above, where the middle, which would have been track 17, track 1, I apologize. Track 1 was removed. The new approach slabs were installed, and space was created for that first superstructure to be moved into place, which was done using SPMTs, which would pick up the bridge superstructure and drive it into its final location, essentially one bay over, as you can see here. So now that northern superstructure was in its final position. New track and ballast was installed, and that bridge was open for service. That all happened during a single weekend, as proposed in our renderings here and during the design phase. So again, just to reorientate everyone, now we're talking about tracks 1 and 17. Old South Track and Track 2 are in service, being carried by the new bridge. So for this southern structure, again, temporary supports, installing and assembling the new proposed superstructure. Once it was fully assembled and in place, during another single weekend shutdown, again, both to commuter rail and freight rail, but also the vehicular traffic below, the existing superstructure was removed. New precast concrete approach slabs were installed. SPMTs were brought into place and moved the new superstructure into its final location. Track and ballast were installed, and the train and the bridges were open for commuter rail and freight rail service. At that point, some of the ancillary work, sidewalks, new paving and striping was installed after all of the bridge work was complete. So here's a photo of the existing bridge in original condition circa 2017, and we had a visualization that showed, again, what we proposed the bridge to look like. At this point, I wanted to mention that all of that sequence, that sequence that I just described, was developed during the design phase, and it's developed in conjunction with the contractor and the engineer and then the MBTA. But as you got through the final end of the design and started the construction, there was some changes that were implemented that affected the order of operations and affected how we actually constructed the project. So how it was actually built doesn't quite match what was shown in those renderings. And at this point, I'm going to turn it over to Andrew Burkholder, who's going to walk through some of those key differences.
Thanks, Bob. Yeah, so this project was a good lesson on being flexible and adapting. Like Bob said, we had this great plan, presented it to the public, just as you saw, and afterwards, the city and the freight operator, they came to the team and they had some concerns with shutting down this area for 2 weekends, both concern by the freight operator for 2 weekends of disruption, and also the city had a concern 2 weekends of closing this roadway, which provides a critical link over a river just north of the bridge, which you may have seen in that map that zoomed in. So at that point, we were already in design, already working out the details, but the design build team, MBTA, the city, we collaborated on a solution that allowed us to use only 1 weekend to complete this work. So again, a reminder of the proposed sequence here, and then let's get into what actually happened. So this picture on the screen shows kind of mid-weekend closure, but a few things to point out. The superstructures are shown here at the bottom of the picture. These were assembled to the south of the existing bridge, so both superstructures assembled to the south rather than one on each side. These were assembled on temporary shoring over Parker Street. So again, minimizing impacts to the users of Parker Street. A few closures here and there to do the overhead work, but for the majority of the time, Parker Street was open while these structures were assembled overhead on temporary shoring. Basically assembled over a 3-month time frame in preparation for the weekend outage. So this is the beginning of the weekend outage in the early morning, September 17th. This is looking to the west. You can see the northern portions of the existing bridge are being demolished. And again, the superstructures, new superstructures sitting over Parker Street are ready to go. So if we head to Friday, at this point, still doing some cleanup from the demolition. You can see the MBTA train still crossing the existing bridge. That track was still active. Also, just after this picture was taken, the installation of the precast back walls and the precast approach slabs was beginning. So that involved drilling into the existing abutments, setting the precast, installing dowels, grouting that all together in preparation for the superstructure installation. So this is looking To the south, obviously looking at the new superstructures getting ready to be driven into place. At this point, the temporary shoring has been removed, fully sitting on these SPMTs. And at this point, what's not shown in the picture, finishing up of the back wall and approach slab installation, getting ready for that roll in. So at this site, SPMTs were chosen for a number of reasons. And one of the biggest ones was the feature that's crossed. Here we have a roadway, a nice area for these SPMTs to move and operate, as opposed to a river crossing where it just wouldn't be usable. It also provided flexibility. So there's a lot of consideration early on in the project that maybe these superstructures needed to be assembled off-site in a parking lot somewhere and driven in. Ultimately, obviously, we chose, or the contractor chose, to assemble these over Parker Street. But you know, having those SPMTs, assuming that that was the way we're going to go from the beginning, offered us that flexibility. All right, so I think this is a short video. It's not going to show the whole thing, but at least gives you an idea of how one of these superstructures was moved into place. So each superstructure had its own SPMT unit underneath. So we didn't, you know, both were ready to go at the same time. They moved individually, but we didn't have to, you know, drop one bridge and move the SPMT back to grab the second superstructure. They were both ready to go. This is an overhead view of that northern superstructure moving into place. All right, and then this is the final condition. So this was taken, you know, not too long after the weekend. You can see there's still some ancillary work that needs to happen, some roadway work, installation of sidewalks, finishing up. But I guess the bottom line is that the roll-in, the replacement was successful. We met the deadline. Tracks were opened Monday morning for commuter rail service, freight service. Everything mostly went as planned. But the important part was the deadline was met. Train service was running when it was supposed to be. So just some fast facts. Each of these bridge superstructures weighed about 220 tons. That was for all of the steel weight. You probably noticed these were moved without the ballast on. The substructure, as was described earlier, we had 26 micropiles. These were 9 5/8, about 70 feet long, and in addition, a 15-foot rock socket. And on the east abutment, we had 12 tiebacks that were 50 feet long. That was the fixed abutment. So wanted to get into some key takeaways and some ABC lessons learned on the project. The first one is avoiding utilities. What was a big driver of this bridge design and configuration and construction was avoiding some of the utilities on the site. You may not have picked up on it, but in the rendering, it showed a transmission line, electrical transmission line just behind the west abutment. This was right where maybe the preliminary design assumed the bridge was going to go, but moving that utility would most likely be years of delay. There was also a force main sewer, a fairly large force main sewer under the eastern abutment, or just behind the eastern abutment. And so again, you know, a lot of times on these projects, we've built constructed abutments behind the existing, but in this case, that really wasn't practical for those utility reasons and added a lot of risk and potential delay to the project. The other, another key takeaway is the close coordination needed with these municipalities or cities, towns where the projects are. So again, it was our close working with them that we were able to pull this off in one weekend. We worked with them about detours, about lighting, about public outreach. That was a very important part of this project, not only for residents of the city, but also users of the T. Another key takeaway is construction tolerances, equipment, site constraints. You saw in these pictures, their overhead pictures, there's a lot going on in a tight site, and it takes a tremendous amount of planning. You know, a lot of people see just the weekend when this gets done, or maybe a few months leading up to it, but they don't fully grasp the amount of planning and preparation that goes in both on the design side, owner side, and the construction side to make sure that the equipment can fit in the locations. It can, you know, lift what it needs to lift. All those considerations and all the planning, it's really important, obviously. Also wanted to touch on precast design and detailing. So as I mentioned, we used precast concrete back walls and approach slabs. These were attached to the existing abutment on the weekend using by drilling in dowels and grouting them to the existing abutment. So one thing we tried to incorporate was some conservatism in the design, and that was because on the weekend, and it happens here, drilling a hole into the existing abutment, run into an issue, a drill bit breaks off, something happens and you can't get one of the dowels in. There was conservatism in the design, there was planning. If you can't get one in, you know, that's okay. We have enough that we can still move on, and it doesn't cause a huge delay. So that was really important, planning for that and talking about that ahead of time. The other part of this was bearing adjustability. And so the superstructures, as you saw, were assembled over Parker Street away from the substructures, and the abutments were cast. And, you know, everything was checked twice. It should fit, no problem, but not all the bearings touched down exactly where we wanted them. And so for this bridge, again, we had a plan. The MBTA, VHB, Majeski, and Barletta, we were all on the same page. We knew what we were going to do if that happened, and we implemented that plan. And so having adjustability in different areas is really extremely important. The other thing I wanted to mention that's not on here was weather. It didn't come across in the pictures, but it was a rainy weekend, and obviously can't do this type of construction if there's a hurricane, a tornado, you know, very extreme weather events. But there was a lot of planning and consideration for the ability to pull this off on a rainy day. You know, these weekends are planned months in advance. The outages, we had to consider that when in the design, so that a little bit of rain wasn't going to stop the weekend. And then I think the last thing on here, design and construction schedule. Again, a very detailed hour by hour schedule for these weekends, and you know, a lot of preparation in the design beforehand to make sure that these weekends go as planned, and the trains are running, as we said, Monday morning. So
thanks. Just wanted to interject
Sure.
regarding the design and construction schedule, is that we've boiled down essentially all of the fun things that happened with this project into that one weekend where all of the construction activities really tend to focus. But the years of planning and programming the work, identifying this project as a need for the MBTA's system, and then going through the design and the permitting, the development of shop drawings, fabrication of the materials, the construction of all the other kind of the pre-work to get us, that has to all go right in order to get to that one weekend. You know, it just doesn't come through in the slides, but there's a lot that has to go right for several years in advance to make sure that the weekend goes smoothly.
Yeah, good point. All right, and I think with that we can certainly entertain any questions that you might have. Thank you.
All right. Thank you for a wonderful and very informative presentation. And by the way, lots of good animations that relate the topics to the audience. So at this point, we are going to turn it to Paul Lyles to moderate the question and answer. Paul, it's all yours.
Thank you, Atari. Carl, Bob, and Andrew, really neat project. Yes, we do have some questions that came in during the presentation, and hopefully we'll get some more. But with that, let's go ahead and look at first of all, the pre-webinar questions. We have a few that came in. The first one was there any special reason for using the self-propelled modular transporters as opposed to maybe a lateral slide or something?
Yeah, I tried to cover it a little bit in the presentation, but I think, like I said, one of the big reasons was flexibility. It allowed us the flexibility. You saw stuff change, right? Our plan changed over the course of design. So having that kind of from the beginning allowed us the flexibility to entertain assembling these off-site and driving them in, or doing it the way we showed. And again, a lot of it depends on the feature crossed. Here we had a bridge only 14 foot 6 inches off the roadway, a nice roadway below, nice and level. So it just it lent itself to the SPMT option here.
Okay. Another one that came in beforehand was, are there more railroad projects in Massachusetts under consideration for similar replacement after completion of this project? Now, that's sort of a two-part question. One of them is you've got some more going on with this overall project. And then do you have any more further down the line?
Sure. The MBTA has an aggressive capital investment program. I mentioned that we were at the start of this, back when this project was released, our spending goal or our investment goal was, just under $1 billion. In the current year, we're estimating that we're going to invest over $2 billion. So we've ramped up even quite a bit in the past 2 to 3 year period. We have an $8 billion capital investment program that is ongoing. A lot of that is infrastructure work throughout the system. So yes, we do have a number of bridges identified and in the early phases of design pipeline to kind of do that. I think another aspect of that question is just that at the MBTA, we're about moving people and we're about running trains. So our outages for construction windows are very limited, and we want to reduce the impact on our customers. And so with that, ABC is becoming our, not our preferred, but it's almost like our only option on a lot of these lines because we have a limited right of way. We're running, over 30 some odd trains a day, and we have to move the people. So.
Okay. Another early question was the drive-in engineering in the new spans a performance-based specification, or was there separate compensation in the contract for the SPMT move?
Carl, do you want to take that one or what?
Yeah, this design build contract was a lump sum replacement of 6 different bridge locations, all inclusive. So it was up to the contractor and the design team to kind of hedge their bets, if you will, and present what they felt was the most affordable and best scenario for the construction. So kudos to Barletta and VHB for getting it right.
Okay, and another early question was, where were the new bridges constructed prior to moving into place? I think you covered that in your presentation.
Yep.
Right. Yeah. Just south of the existing.
Okay. And then there was a question early on about, please discuss impacts of weather, scheduling, and contractor claims on the bridge project. Some of that you've covered already.
Yeah. Try and plan ahead for, again, a rain event, a weather event, make sure that our design and it's not contingent upon that type of weather, because you plan so far in advance that we need to be able to do them in most weather conditions.
Okay. And you consider the ABC cost effective for this project, I think. I don't know if you really had any other option on it.
No, it was the only option by the contract.
Okay. All right. Let's look at some new questions that have come in. There was a question that came in right as you started about, since this was a design build, what type of agreement was with the railroad in terms of their sign off on the bridge, and how much was it? Now, do y'all own this bridge?
Yes, sir.
Okay, so really the agreement was y'all were controlling it, so it wasn't. Now the railroad that's there, are they just on your right of way? Is that what they do? That freight railroad?
That is correct.
But y'all get to tell them what you're going to do. Is that right? Okay. Let's see. There's a couple questions about the tiebacks, and I think we've had some more even after that. But it is not clear to me, this is what the person asked, if you use two groups of tiebacks on each side of the old abutment, one for the old abutment and another for the new abutment, or did you just drill through the old abutment and put in one group of tiebacks that went through both of them, the old and the new?
Yeah. So the idea was to kind of marry the two, the old and the new, marry the old abutment with the new cast in place part. And so the tiebacks were installed, I think it was shown maybe on a couple pictures, but the tiebacks were installed through the existing abutment before the new abutment was cast. So the tiebacks get installed and stressed. There was a big plate on those tiebacks and a lot of reinforcing steel on that plate, and then micropiles installed, and then everything cast in place concrete installed and kind of pulling it all together. So it acted in the end. It was designed to act like a monolithic abutment, the tiebacks taking the lateral loads and the micropiles taking the vertical load.
Okay. Then there was one about were the tiebacks installed only to help with the lateral force due to the construction from the crane right behind the abutment?
They were installed to take the lateral design loads of a modern ARIMA code. So at the fixed abutment where we're resisting those lateral loads, we're using passive resistance of the soil for one direction, and then the tiebacks helping in the other direction.
Okay. You mentioned discussing with the contractor during design. That was mentioned. Does it mean the contractor was selected early, or would you just happen to be talking with them, the person that got the contract?
It was a single design build team, which included the general contractor as the lead agency and the designer as the subconsultant.
Okay. Question that came in: was the station removed adjacent to the bridge?
What you can see is remnants of an out of service station that was not. It is not currently open. It was not removed, but it's just existing infrastructure that's adjacent to the project.
Okay.
There was a portion of it that was removed, just a small portion near the bridge, but again, it's not in service.
Really not in service. Okay. Yeah. That got through most of the questions, but we have a whole lot of them that have come in since we started the question and answers. So I'm going to turn it over to Jugash, and he's going to go through these questions. There's a whole bunch of them. They're pretty good. Jugash?
Yeah, thank you, Paul. So the first question that came in while Paul was answering the questions was there a backup plan if the bridge erection caused delay to the railroad?
There was a in place, if we're talking about the weekend, that's what the question's asking about. There was in place substitute emergency busing to kick in on that Monday morning if needed.
Okay, thank you. Could you share with us the lessons learned or what you do differently given this experience?
Yeah, I guess we went over some of the lessons learned in the presentation, at least the major ones. I think, again, the bearings we learned about on happened to be another bridge on this project, and so we had that in place. But in the future, I think we would have that right from the start, the adjustability of those. Not sure if there's others that can come to mind. It went, I think, pretty smoothly.
Okay. Did you build the superstructures offline at the final proposed elevation, or was it built low to the ground and raised for the SPMTs?
They were generally built at the final elevation. So, just a little bit higher. Obviously, they have to drive in and drop them down, but they were built, essentially at their final elevation up in the air on temporary shoring.
Okay,
I think
thank you.
you mentioned,
Go ahead.
you mentioned, Andrew, that they were in place for about 3 months ahead of the weekend, and so we had to maintain traffic under the existing and the proposed in a temporary location. So we had to maintain at least the 14.6.
Right. Yeah. Good point.
Thank you. Could you elaborate on bearing adjustment problem, solution, etc.?
Sure. So, ideally you want, when you're setting this superstructure unit down, there's 6 bearings, and ideally they all touch down perfectly at exactly the right elevation. And for whatever reason, and seen this happen not only on this project, but others, they don't all, there might be a very fraction of an inch difference, and a bearing isn't in contact. So the solution that we used was to install shims temporarily to take the load, and then use a product, install basically like grouting a base plate, grout product under that bearing to achieve the full bearing area. And it worked pretty well.
Okay, thank you. The next question is, were there any utilities under Parker Street to be concerned with from the pressures induced by the SPMT trailers?
At this location, I think there was some drainage and other utility, minor utilities in the street. We do receive calculations typically from for the movement plan that looks at those pressures and usually compares them to a typical truckload to show that we wouldn't be increasing those significantly, or if we were, there's some options to mitigate that. You saw some steel plates in this case.
One of the advantages of SPMTs is that you've got so many axles that you've distributed that force, so you are essentially, you're shooting to get equivalent to a typical truck.
Yeah.
Right. Okay, thank you. If the sewer was not behind one of the abutments, would the design have reverted to new foundations behind the abutments?
I think that it was a combination. So unfortunately, we had a sewer behind one abutment and the utility behind the other. So I think the sewer alone wasn't the issue. It was a combination between the two, which led us to do what we did. As you saw in the presentation, if there were no utilities, we may have considered going behind.
Andrew, just to add to that, the overhead high tension power lines, if the screen is still showing the last slide of our presentation, the aerial view of the finished bridge, you can see that one of the poles that hold up that high tension line, that was the primary driver. Geometry.
Okay. Next question, how do you manage the existing utilities from the old structures to the new ones? Not sure what they mean. How do you manage? Are they talking about the connection possibly?
Yeah.
Probably more the rail utilities, I would guess. You can see the. Go ahead, Brian.
Yeah, go ahead. I was going to jump in, but this particular bridge did not have active utilities being carried by the bridge structure itself. So in this particular case, that was not an issue. The other way to deal with it on several of these bridges that it has been a problem is to temporarily relocate that existing utility off of the bridge structure, whether it be overhead or a workaround, replace the bridge structure, and then put it back onto the bridge, as opposed to dealing with the utility on this outage.
Okay, thank you. What was the connection between the precast track slabs and back walls? Did you use grout splice sleeves?
Yeah, we had so between the back walls and the precast approach slabs, there were holes that lined up, and then dropped in a dowel piece of rebar, and then a grouted connection.
This question has come in a lot of times. It says, what was the reason for the tie-back anchors? They appear to anchor the existing wall abutment into the backfill and do not appear to anchor the cast in place concrete wall extension into the existing abutment?
So what, probably didn't come across in any of the pictures. We could show a detail at some point or show how it worked, but there was a large plate that was put. So a typical tieback might have a small plate that goes on the end of it, and in this case we had a larger plate. I don't know, it's 2 feet by 2 feet, something like that, with a lot of reinforcing steel that was welded to it, and that served as the connection to connect, again, the two abutments together. There was also more dowels, but that connected the old abutment to the new abutment, and also transferred the load between the tieback, the old abutment, and the new. So it was designed to act all as one in the final condition. Another way to do it, I guess we could have cast the abutment against the new abutment against the old and install a tieback through the whole thing, but then that cuts into the sidewalk, potentially cuts into the sidewalk width, which we wanted to maintain.
Okay, thank you. The next question, did you use the existing bearing or a new one? If the old one was used, then how old was it?
All new bearings.
All new bearings. Okay, good. Thank you. And then the next question is asking about, were the micropiles welded to each other during the time of driving? And I suppose the answer is pretty easy for that. I'll let you answer it.
I'm pretty sure they have us, they screw together.
Yeah.
Yes.
Okay. Who performed the track work? MBTA or the contractor?
It was the contractor.
Okay. Thank you. What was the total cost for this bridge?
It's part of a program. The total program, all 6 bridges, is $90 million. It's the design bid price. I don't have that information to dig down for this bridge right here.
Okay. Were there any utilities that had to be relocated as part of this project?
I don't think so in this case. I think there were some abandoned utilities on the bridge that were removed, and as Brian said, we didn't have to deal with utility relocation. I think a lot of these questions maybe are coming in because we do show conduit on each side of the bridge, and this is conduit that's installed for future utilities. We didn't have anything running through it, but in the future, it's there for the MBTA's use.
Okay. Was the existing abutment concrete or masonry?
In this case, it was concrete.
Is there any
abutments.
All right, thank you. Is there any fatigue analysis on the track? What and how the maintenance routine will be considered?
I don't know. I don't have.
That's an operational issue. That's not a bridge construction
Design. Okay.
Yeah, I'm not sure I have the answer to that.
What modifications, if any, were made to the existing abutments to ensure a 75-year life?
So a lot of the concrete at the face that was, judged to be in poor condition was chipped off and removed. In cases where the new abutment was cast up against it, it protects it, and then in other cases there'll be a new concrete face put on to protect it.
Okay, thank you. If the assembly area was to the south of the project and the north line was constructed first, how was the north structure passed under the south line that was kept in service?
It maybe was a little misleading in the pictures. In the end, the pictures we showed the northern bridge being demolished and there was operations on the southern, but what wasn't shown was at some point that track also got shut down and the whole bridge was removed. So there was no passing under. At one point there was no bridge at all between the abutments, and then both proposed superstructures were driven into place from the south.
All right, thank you. Given the limited space, was a load test on the micropiles waived, or was it performed off to the side of the bridge on a sacrificial pile?
It was performed on a sacrificial pile, not under the bridge, in a location where we had room to to perform the load test.
Okay, thank you. Did you consider using SPMTs for demolition?
We
brought it
have
up.
considered it. We do consider it from time to time. In this case, we did not utilize the SPMTs for the demolition.
Okay, thank you. Was the project design build or design bid build?
Design build.
Okay. How much time was allocated for track construction? Was this done by the contractor or the railroad? I believe we've answered this before.
Yeah, the track work was done by the contractor and included in our schedule for the weekend.
Okay, thank you. How long did it take to assemble the SPMTs under the bridge and be ready to move?
Brian, do you want to take it? I'm not sure.
Yeah, it takes, a few days to mobilize and get them set up at a minimum. Some of which
Okay.
can be done prior to blocking roadways.
All right, thank you. Are approach slabs typical in railroad bridge construction?
Yes.
Okay. Next question, we are approaching the end almost. It says, you mentioned that the track profile did not change. Did the low steel elevation have to increase at all? Or did the existing bridge have the required 14'6" clearance already?
The existing bridge was lower. Not sure if you see it in the different pictures, but the way we made up the difference was to use a pedestal at the ends of the girders. So there was a steel pedestal that made up that grade difference and allowed us to increase the vertical clearance by keeping the tracks at their existing profile.
Okay, this is the last question. How did you manage to get the best price for construction if the contractor was already chosen from the beginning?
The contract was, the price was also set at the beginning. So he was the low bidder before any work was performed.
It was design build best value, so it was a combination of tech score and bid price. So that number was already baked in.
Okay, thank you to everyone for all the answers. I am done with my list. I'll turn it back to Adarad.
All right, thank you, Yogesh, thank you, Paul. Thank you for a great presentation with everyone. And we are glad that actually we saw this, the sharing of this information in the social media. And like Carl said, if you have an interesting project, please let us know. And we'll be more than happy, our executive committee, to consider it for a monthly webinar. So on that note, again, we would like to remind you that in December of 2022, we are going back to face-to-face conference. It's going to be in December of the 2022 in Miami, Florida, and we look forward to see many of our colleagues that we have not seen for some time. So on that note, we will conclude this webinar and hope to have you with us again. Bye-bye.